What's up, everybody? It's Dan from SageMathTutoring.com, and here is a video pertaining to a test review. This would be 8th grade math, and I have a student who has a test coming up, and we're going to cover some of these concepts right now. There's actually two test review sheets, so we're going to do both of them. All right, so looking at this one, write an algebraic expression for each verbal expression in problems 1 and 2. So, uh, in problems 1 and 2. Okay, cool. All right, so first of all, they say the sum. So that means it's going to be something plus something else. It's going to be something plus something else. That's what the sum means. For my student who's watching this, you might want to do that. You might want to be like, okay, it's going to be something plus something else. And then the question is, well, what are the things that are being added together? Well, one of the things that's being added is 1/3 of a number, and the other thing that's being added is 27. So we have 1/3 of a number and 27. And how could we say 1/3 of a number? Well, that would be 1/3 x, because we do not know the number. 1/3 of a number. The word of very often means multiplication. So it's 1/3 of some number we don't know. 1/3 times x. And the other number is 27. So we could write that here. All right, so the final answer would be 1/3 x plus 27. Hopefully that makes sense. Looking at problem number 2, the product. Okay, so first of all, they said the product, right? So product means multiplication. So multiplication, we could use a little x, maybe use an asterisk because we're using x's for variables. So the product of what? Some number, okay, squared, which we'll worry about later, and 4. So 4 belongs here, right? Right, 4 is right there. I don't know what's up with this 4. It's very artistic looking 4. So it's going to be the product of some number squared and 4. Well, some number squared would be x, and then to square it means we have that exponent of 2. All right, so that's actually the answer there. The teacher would probably accept that, but I will say it would be customary to write 4x squared instead. So that's that one. Write a verbal expression for this. Okay, so this one's a little trickier, right? Write a verbal expression for that. Well, let's see. If we write a verbal expression for that, I would strongly recommend focusing on the big picture. The big picture is that it is certainly addition happening. So I would immediately start saying the sum of, right? And then it's going to be this blue part plus the white underline part. So the blue part would be, I would strongly say 5 times a number cubed. I would actually say 5 times the cube of a number. The cube of a number. Because I want to make sure it's clear that it's only that number that's getting cubed. And this is the word we use to say this is the other thing we're adding. 9. I feel like that's it. It's pretty good. The sum of 5 times the cube of a number and 9. All right. 5 times the cube of a number and 9. Okay. Evaluate. Now, my student who is watching was wondering, evaluate. Evaluate just means like, what does this actually equal at the end of the day? If we simplify all this, what does it equal? So I think my student recognizes PEMDAS is the way to go, oftentimes for simplification. And the P stands for simplify that which is inside parentheses. Simplify that which is inside parentheses. So we're going to do that. So we have 3 squared. I'm just going to rewrite everything. 12 minus 4 divided by 2. So this is the parentheses here. So we're going to simplify that. We have 3 squared equals 8 divided by 2. Now we have to simplify the brackets. It's kind of like you're going from the inside out. So it's going to be 3 squared times 4, because 8 divided by 2 is 4. That's going to be 9 times 4. And for my student watching, use your calculator if need be. That is 36. Okay, now 3 squared is 9 because I applied exponents. Notice how all these steps had to do with the parentheses. Had to deal with these parentheses, had to deal with the brackets now. And once I had that, only then could I worry about the blue exponent scenario. And this is where I started processing the exponent. And then at that point, we can deal with multiplication at that point, only then. And then it becomes 36. Okay. Looks like we will be doing something similar. Well, at least we're evaluating for problem number 5. We're going to be evaluating 4w plus v minus 5t if w is 2, v is 8, and t is equal to 4. So I'm going to strongly recommend just drawing some empty parentheses for w. Um, Empty parentheses there is fine. And then empty parentheses here. So for w, we clearly have 2. For v, we have 8. And for t, we have 4. At that point, PEMDAS will apply. Simplify anything that is inside parentheses first. So I'll mark it in green. We have parentheses here. Let's simplify that. So it's going to be 4 times 2, which we'll worry about later, plus 3 times 4. At this point, we have multiplication happening, multiplication happening here and multiplication happening here. So at that point, we are on the M for multiplication. So we're looking at 8 plus 12. At that point, we can move on to addition, right? And that's going to be 20. And then we're done. And then we're geniuses. All right. Name the property used in each equation. Okay, so for my student who's watching, there is a reference guide. And actually, here it is. Here's a reference guide. Okay, how about that? It's magic. So we have this amazing reference guide, and we want to know what property is this when we multiply 11 times n, and that equals 1. Well, what would that be? Well, it's kind of a weird one. I actually don't like this as a teacher's being mean. But my question is, where in the properties do we see a scenario where if you multiply something by something else, it becomes 1? Well, I see it here. I see it here, okay? The multiplicative inverse property. Because the reality is that if you look at this, for my student watching, just remember, this is a fraction times its reciprocal, that equals 1. Now, I know that 11 is not a fraction, but you could think, hypothetically, of 11 as 11 over 1 secretly, because every number, like 11, has a little 1 underneath it. It's just invisible typically. So if we multiplied 11 times n, well, according to the multiplicative inverse property, that's the reciprocal of 11 over 1, aka 1 over 11, and that would equal 1, right? Okay, so that means that n has to be 1 over 11, okay, which happens to be the reciprocal of 11 over 1, okay? Once again, every whole number secretly has a 1 underneath it, okay? Now, the challenge here is knowing which of all these properties. A lot of properties here, right? So for my student watching, you got to kind of understand this. Additive identity, okay, anything plus 0 is just itself. Additive inverse, oh, okay. Anytime you subtract a number from itself, it becomes 0. Multiplicative identity. Anytime you multiply a number times 1, it remains itself. Multiplicative property of 0. Anytime you multiply a number times 0, it's just 0. Multiplicative inverse property. Anytime you multiply a number times its reciprocal, you're going to get 1. Reflexive property. Every number equals itself. Symmetric property. If A equals B, then it doesn't matter which way we write it. We could also say that B happens to equal A as well. If A equals B, well, clearly B equals A. Transitive property. If A equals B and B is equal to C, then A has to be equal to C. This is a train. The B is the connecting link. It's a train. It's like train cars. The B is the connecting link. If this is equal to that, and by the way, this is equal to C, well, guess what? A is equal to C. Done. That's transitive. Substitution property. If A equals B, that means anytime you see A, you can replace it with a B. For example, if I know that X equals 3, that means anytime I see an X, anytime I see an X, well, guess what? I can replace it with a 3. Why not? And the reason why that is justified is because we already established x equals 3, and according to the substitution property, I can literally substitute 3 in for x at that point. That's the substitution property. Okay, anyway, this one, 7 plus n equals 7 plus 3. Okay, so for me, that is probably going to be the reflexive property. Reflexive property, pretty sure, because um, something on one side equals itself on the other side. So in order for this to equal itself, then n would have to be 3. So I'm going to say reflexive for that one. All right, name the property used in each equation, then find the value of n. Okay, so this one's kind of interesting. We're going to still rely, there's always sort of a question of like, am I presenting exactly what this specific teacher is looking for? But we're gonna do our best. So, not really sure why that's happening. So, looking at what's happening, technical difficulties. That's what's happening. So, over here, looking at this, evaluate this, name the property used in each step. So first of all, it's going to be 6 times, and then this part right here becomes just 6. All right, and then we have divided by 36. And that right there was the multiplicative identity. Multiplicative, I'll just write it like that, ID for identity. And that's literally this one, because for any number, a times 1 is just itself. And that's exactly what we did, where it was 6 times 1, so it just remained itself. Now, this next move, I'm not so sure if there's a name for it, but 6 divided by 36 is really 6 over 36. I mean, that's just a fact. And that does reduce to 6 times 1 over 6. Whether or not the teacher wants a name for that, I'm not so sure. But I do know that the next step is to say that this is equal to 1. And the reason is because of the multiplicative inverse property, which is what we already discussed, which is right here, that says any number times its reciprocal is equal to 1. Well, that's what we're doing here. It's 6 times its reciprocal, because remember, 6 secretly has this 1 underneath it. So 6 over 1 times 1, 6 equals 1. So that's multiplicative inverse property. So that I feel good about. The only thing I feel a little less good about is whether or not the teacher wants us to provide a name for how 6 over 36 could then turn into 1/6. Okay, continuing on. Rewrite this using the distributive property. So the distributive property says that if you have a number that's on the outside of parentheses, that's being multiplied to the parentheses, well, you could just multiply it to the things that are inside the parentheses. So that's going to be 5 times 10, which is 50, plus 5 times 3, which is 15, and that's going to be 65 at the end of the day. Now, my student watching might be tempted to not do that. My student watching might say, oh, 10 plus 3 is 13, 13 times 5, let me just do that. So that's true because we have been trained to use PEMDAS. We've been trained to simplify the parentheses first and then take it from there. But the directions are specifically saying to use the distributive property, so we're going to do this, okay? Simplify each expression. Okay, so yeah, so these blue boxes are like terms, and the way that I know that they're like terms is that they have the same variable and the same exponent, right? This is z squared, so that's not a like term. So that means that only the blue box like terms can get combined. And when you combine them, you add the coefficients, which turns it into 11w squared. And then we have plus z, 7z squared, okay? So then we're done. Notice how the w squared just remained w squared, right? We have 4w squared, 7w squared. You added the coefficients, you kept the variable as it was, and there you are. If we're going to simplify this expression, I'm going to strongly suggest using the distributive property, okay? Now, in a way, that's adhering to PEMDAS because PEMDAS says, if we use the distributive property, PEMDAS says that before you do any adding at all, you should multiply, right? Now, of course, we should double check. Can we simplify that which is inside the parentheses? Well, 5x plus 2, unfortunately, inside the parentheses, we cannot simplify that any further. We're kind of stuck there. So we can move on to exponents. There's no exponents. We move on to multiplication, which is what we're about to do with the distributive property. So after distributing, we're going to have 20x plus 8. We have a like term here. We have a like term here. We can combine them. That's going to be 23x plus 8. And then you're done because this is a constant. This is a term that features a variable, and you cannot combine those because they are not like terms. You are stuck with that. Evaluate each expression. Well, the reality is we could just kind of do this in any order that we want, actually. That's a property of multiplication called the associative property. It actually doesn't matter which ones you multiply first, which numbers you associate first, which two numbers you choose to multiply first. I'm going to strongly recommend doing that because that's easy, 4, right? And we have 5 times 13 times 4. Then I'm going to suggest, multiply 5 times 4. That's easy. That's 20. So it's 20 times 13, right? 5 times 4 is 20. So it's going to be 20 times 13. 20 times 13 might be a little trickier, but it turns out that that's 260. All right, so that's that one. Now, could you have multiplied 5 times 13 and then figure out what that is, and then multiply that times 4, figure out what that is, and then multiply that times 1? Yes, you could definitely do that. All right, so for my student watching, if you'd rather just go in order, that's fine. Okay, similarly, we can add whatever numbers we want first. I'm not seeing any, well, okay. If we add 6 plus 14, that's just 20. So we would have 17 plus 3 plus 20. And then 17 plus 3, that's 20 as well. So it's 20 plus 20, which happens to be 40. All right. Now, for my student watching, did you have to do it in that weird order where I added 6 plus 14 first, and then I was, 17 plus 3, that's also 20, right? I'll draw it up here. That's also 20. Did you have to do it that way and then add 20 plus 20? No. You could have just done it 17 plus 6 is some weird ugly number, plus 3, some weird ugly number, plus 14, and then you're done. Okay, looking at the next thing. Identify the independent and dependent variables. Use the graph that shows the bowling scores. Okay, so for my student watching, it is often the case that the independent variable is associated with the x-axis and the dependent variable is associated with the y-axis. So the x-axis is this blue horizontal axis. The y-axis is this green sort of vertical one, okay? So this is clearly the x-axis. So I'm going to say the independent. So we want to say that the independent is associated with the x, whereas the dependent is associated with the y. So we're going to say that the independent is the game and the dependent is the score. Now, one way of seeing it is like if somebody asks you, hey, what was your score? You could say to them, well, it depends on which game you're talking about. It depends on what game you're talking about. So in other words, the score is dependent on what game it was. Okay? So the score is dependent. That's sort of another way of thinking about it. All right? Describe what may have happened between the first and fourth games. Okay, so between the first and fourth games. Well, obviously, there's a lot of room for creativity here. Maybe the person was old and they got tired after the third game. Okay. They're doing really good. They're warming up. First game, doing better. Oh, second game's even better. You know why? Because he's warming up. Third game, he did even better. Look at the score. It's so high. And then all of a sudden he got tired. You know why? Because he's old. and then he went down here. Okay, so a lot of room for creativity there. Describe what may have happened. That basically means make up a story. That's that one. 18, write the data as a set of ordered pairs. Okay, so it is often the case that if you're presented with a table, this is like the X and this is the Y. And ordered pairs are like X comma Y. Okay, so really the ordered pairs are going to be 2.0 comma 2.0 comma 1.80. Another ordered pair would be 3.0 comma 2.75. Another ordered pair obviously would be 4.0 comma 3.70. And then another ordered pair would of course be that last one, right? So remember, for my student watching, parentheses, comma, the first number goes, the first number goes here, second number goes there, first number goes here, second number goes there. It's also the case, we could call this the X column, this is the Y column. And by the way, money, whenever money's involved in a real world problem, that's usually the Y, okay? So if you were to graph a scenario, remember how I said X-axis, Y-axis, right? Well, typically this is the money axis, all right? You know, the cost or how much money you're making, depending on the X. All right, so blah, blah, blah. Problem number 19, draw a graph that shows the relationship between the weight of a letter sent airmail. So basically they want a graph of this, right? So we have 2 comma 1.80. So that would be, you know, here. So the weight is here, that's 2. And then 1.80 would be like right around there. So I'll color code this. This is red. We'll make this one blue. We'll make this one green. And we're going to make this one white. So the red dot is 2 comma 1.80. So remember, it's 2 first here, and then 1.80, which is right around there. The blue point, 3.0 comma 2.75. So 3.0 comma 2.75, right around there. The green point is 4.0 comma 3.70. So that's going to be like right here. And then finally, the white point would be 5.0 comma 4.65, 5.0 comma 4.65, 4.65 would be right around there. Okay, looks kind of straight, to be honest. Draw a graph that shows the relationship between the weight. Okay, we just did it. All right, there it is. There's the graph. So for my student at home, remember that first number is the horizontal axis. The second number is the vertical axis. You must remember that. I'll say it again. The first number is the horizontal axis. The second number is the vertical axis. All right. If I say it too many times, I sound angry when I'm not. Problem number 20, interpret the end behavior of the function. I think all the teacher wants there is as x increases, y increases, which we're not done yet. This is just a template. As x increases, y increases. Your teacher wants something like that. Your teacher wants you to basically say, as this goes to the right, the y value is going up. But since this is not labeled x, this is not labeled y, what we should actually say is, as the weight increases, the rates increase. Okay? That's what the teacher wants for quote unquote end behavior. What's happening to this as we go to the right? Okay, unfortunately, I don't have time for the bonus. This is a lot of guessing and checking. It's like wrapping parentheses until you get something that equals 4. It's a bonus. I don't care. It's not even math, to be honest. Well, it is kind of math, but it's, again, guess and check. I don't care about that. Okay, so all of this has the answer written, but it's important that we understand why the answer is the answer. So let's look at problem number 1. Write an algebraic expression for 3 times x squared minus 4 times x. Okay, so 3 times x squared minus a subtraction 4 times x. Okay, easy peasy. Really didn't require that much of an explanation. All right, write a verbal expression for that. Okay, so perhaps understanding the answer has more to do with translating each potential answer choice and then realizing the only one that would work. F says the product of 3n and 8. That literally means 3 times n times 8. Is that correct? No, get it out of here. Uh, answer choice H says 3 times n less than 8. Okay, so that says 3 times n less than 8, meaning 8 minus n. Okay, less than means subtraction, and it means switch the order between these two. All right, you know you're dealing with subtraction if you have minus, that's subtraction. Okay, but if I say 3, if I say 3 or 11 minus 7, well, notice how 11 minus 7, well, that preserves the order. The 11 comes first, the 7 comes next. However, there's a couple of subtraction words where you have to switch the order. One of them is less than. That's certainly subtraction. Another one is fewer than. That's subtraction. Another interesting one is subtracted from. Yeah, subtracted from. Anytime you see these phrases, it means subtraction, but you have to switch the order. For example, if you say 3 less than 10, well, that's literally 10 minus 3. Notice how I switch the order of the numbers. If I say 5 fewer than 2, well, guess what? 2 minus 5, that's what it means, and so on. I don't even need an example for that one. So, anyway, that's the explanation here. 3 times n less than 8. 3 times 8 minus n. Cool. Let's look at this one. N minus 8 times 3. N minus 8 times 3. 8 times 3. That's not what we're looking at up here, right? Now, the only one that works is this one. 8 less than the product. So that means this product comes first. What is the product of 3 and n? That's 3n. 8 less than that, minus 8. I already told you, anytime they say the phrase less than, it definitely means subtraction, but it also means switch the order. So the 8 comes last. 8 comes last. All right, hopefully that makes sense. Evaluate 4 plus blah, 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 blah. So definitely going to want to use PEMDAS for that. So I'll write it off to the side. 4 plus 5 times 7 minus 1. PEMDAS says multiply first before you add. So that becomes 35. So we have 4 plus 35 minus 1. At that point, you can do addition and subtraction, and it really doesn't matter what order you do that in. You literally just go from left to right. So 4 plus 35 is 39, minus 1 is 38, and then you are done. Similarly, evaluate for problem number 4. Let's just clear some of this stuff. We're going to make some room, you know what I'm saying? So, more evaluation. Awesome. More evaluation. So we have 3 times 16 minus 9 divided plus 12 divided by 3. So PEMDAS says do the parentheses first. 16 minus 9 is 7, I think, plus 12 divided by 3. Now we could do multiplication and division. So 3 times 7 is 21, plus 12 divided by 3 is 4. Then we do addition, 25. Okay, so that's that. Evaluate m squared plus MPT if it's the case that m equals 3, t equals 4, and p equals 7. So once again, I'm going to do empty parentheses. And m apparently equals 3, so that goes here, p equals 7, so that goes here, and t equals 4, so that goes here. PEMDAS says we should apply exponents before multiplying, so we're going to have 9 then we should multiply, and you can multiply all straight across. 3 times 7 is 21. 21 times 4 is 84, I believe. And then 9 plus 84 is 93, and then you are done. Looking at problem number 6, which equation illustrates the additive identity property? Well, once again, we have our properties, right? We have a list of properties. The additive identity property, I'll just tell you, is a plus 0 equals a. How about that? A plus 0 equals a. Well, guess what? That's right here. It's happening with this green part, right? The green part says 9 plus 0, well, that definitely equals 9 on the other side. This is the multiplicative identity. This is the zero property of multiplication, multiplicative zero property, and this is the multiplicative inverse property, okay? So we want the additive identity property where a plus 0 equals itself. What just happened? 9 plus 0 equals itself. Okay, evaluate this. Blah, blah, blah. Okay, so PEMDAS would have us do the parentheses first. So we will be doing that. I'm going to copy it. 16 times 1 plus 4 times 18 divided by 2 minus 9. So 16 times 1 we're going to leave alone for now. Simplify the parentheses first. We have 9 minus 9. What is that in the parentheses? Well, that is clearly 0. So we have 4 times 0 there. 16 times 1 plus 4 times 0. At this point, we can begin to multiply. 16 times 1 is 16. 4 times 0 is just 0. So guess what? We're left with 16 because it is the case that 16 plus 0 is just 16. So that's that. Okay, problem number 8. Looking at problem number 8 now. Simplify all that. Well, we have like terms in the blue box. Like term in the blue box. Guess what's not a like term? This is not a like term. Why is the blue box like terms? Because they both have the x squared. What do you do with like terms? Well, you add the coefficients. That's going to become 17x squared plus 5y to the third. You are done. That's it. That should be the answer. Problem number, next. Problem number 9. Well, you have parentheses, and honestly, you could simplify this first, actually, of 2 times 7m plus 5m minus 3m. And these are like terms, which means you could combine them. So we're going to have 7m plus 2m. At that point, PEMDAS says we should simplify this even further if possible. Well, you can't simplify it any further, and the reason is because these are not like terms, so actually we can simplify it further. But what can we do? We can move to the m in PEMDAS. We already did the p. We already simplified the parentheses as much as we could by combining like terms. This is simplified as much as we could, so we've already satisfied this. Now we're moving on to m, which means multiply something. 2 times that, 2 times that. That's the distributive property. It's going to be 14n plus 4m, and then you are done. Problem number 10. Use the distributive property to find that. Okay, they specifically say use the distributive property. Distributive property means takes this and multiply it inside the parentheses, into the parentheses. 7 times 11 is 77. 7 times negative 8 is negative 56. 77 minus 56. Well, that's going to be 1. That's going to be a 2. And it's 21. Problem number 11. Simplify that. Well, this one, they definitely want us to use the distributive property. You could totally tell just by looking at it. All right, you have numbers on the outside of parentheses. It's all crazy. So distribute, 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 distribute. We're going to do that. 3 times 5a, 15a. 3 times b is 3b, so it's going to be plus 3b. 4 times a is plus 4a. 4 times 2b is plus 8b. We have like terms here and here. We have like terms here and here. Why are they like terms? Because they feature the same variable. And the variables have the same exponents. Secretly an exponent of 1 there. Secretly an exponent of 1 there. So these are the same variable, we could say. 15a plus 4a, the blue part, is 19a. 3b plus 8b. The green part is 11a, 11b, so it's going to be plus 11b. This is an a. And then we are done. Problem number 12. Evaluate 4 1/5 plus 9 plus 2 3/5. If you're presented with a problem like this, I would add the mixed numbers first. Now, one way of adding 4 1/5 to 2 3/5 is to stack them and kind of go old school with it. And when you add the fractions, 1/5 plus 3/5, well, you keep the denominator and add the numerators. And then you get a 4 plus 2, which is 6. So really, the blue guys become 6 4/5. So we have 6 4/5 plus this 9 left over, right? Well, if you think about it, that's just 9 units plus an additional 6 units and another 4/5 of a unit. 4/5 of a unit. So that's like, if you divided this into 5, it would just be this shaded region here. Okay, so it's kind of a weird model that I just presented, but that's the 4/5. This is the 6th, and this is the 9 units. Now, does this mean you have to draw it? No, but you should understand that that's what's happening. 9 plus 6 4/5. 9 plus 6 4/5. So that's going to be 15 4/5, right? 9 plus 6 is 15 plus the 4/5. So 15 4/5. So again, for my student watching, add the mixed numbers first. We did that. Became 6 4/5, and then use this kind of reasoning process where it's going to be 9 units plus 6 units plus another 4/5 units. Well, that's 15 4/5 units. Okay, looking at this one. Which statement best describes the daily stock price? Okay, so the price went down, and then sometime before noon, it leveled off. Okay, so the price declined sharply and then leveled off. They're literally using my words. Went down and then leveled off. Fine. What's the domain? Please, for my student watching, the domain is the x values, the x coordinates that are involved with each of these points. So we have a red point, we have the blue point, we have a white point here, we have this green point, we have a black point, we have a purple point, right? We have our yellow point, and we have our pretty color, light sort of neon point right there. Now the red point, what are the coordinates? That is -4, comma, -1. What are the coordinates for the blue point? The blue point is -2, comma, 0. Hopefully that makes sense. What is the white point? The white point is -1, comma, -4, it looks like, right? And what about that green point up there? The green point is -1, comma, looks like that's 4. It's kind of hard to see and maybe annoying on the eyes, but we're going to go with it. What's that black point? The black point is 0, comma, 3. What is that purple point? The purple point is 1, comma, 2. What is that yellow point? The yellow point is 1. Oh, man. I'll do it up here. 1, comma, 4. What is that awesome, pretty color other point? That is 4. I'll do it down here. The pretty color point is 4, comma, -1. So the domain is all the x's, all the x coordinates represented in those points. That's the domain, all the x coordinates, okay? So in other words, it's going to be -4, -2, -1, -1, 0, 1, right? 1, 1 and 1, and 4, right? 4. So do we see that anywhere? I think it's H. I think it's H. Unless I'm wrong. Yeah, -4, -2, -1, 0, 1, and 4. Yeah. So notice how 1 and 1 were repeated here, but you only need to list it once. If you're mentioning the domain, if there's a repeat, you just mention it once. Which is a true statement about the relationship? Relation. Well, it's not a function. I already noticed that because you have points stacked one on top of each other, so this would fail the vertical line test, right? It's also the case that anytime you have a repeat in x values, like you have an x coordinate of 1 here, you have an x coordinate of 1 here, if you have a repeat in x coordinates, it's not a function. Okay, so is there anything else true though? Let's see, the value of x increases as y decreases. No. Value of increase, no. Relations are linear. No, it's definitely not linear. It doesn't form a line. Problem number 18, determine which relation is a function. Okay, well, this is not a function because it fails the vertical line test. If you were to draw a line through there, it would hit 2 points at the same time, so therefore not a function. It fails the vertical line test. Similarly with this, if you pass the vertical line through this thing, well, it would hit multiple points at the same time, so it's not a function. So neither of them. Okay, neither. No, no. Okay, what about this? Okay, you know it's a function if there's only one arrow coming out of these points on the left. And it is the case, it's only one arrow coming out of these points on the left. So this is a function. Okay, you know it's a function if there's only unique x values here, if there's no repeats, but we have a repeat in x value. We have a repeat in x values. So that means it's not a function. Okay. All right, interpret the x-intercept of the graph. The x-intercept's right here. It's where it crosses the x-axis. So weekly payments of 10 corresponds with a loan balance of 0. So that means that after 10 weekly payments, her loan balance is 0. So for my student at home, you might already know this, but a loan balance means if you borrow money from somebody, maybe you borrow from a bank, they call the money that you owe them a balance. And the moment the loan balance becomes 0, guess what? You paid off all the money, you paid it all back, and you don't have to pay them back anymore, okay? Because the balance is now 0. The loan balance is now 0. So D, right? She paid off the loan after 10 payments. She did 10 weekly payments. Guess what? No more loan balance. She's done. Problem number 20. Interpret the end behavior of the function. Yeah, so the payment amount, the amount owed decreases. So the loan balance is how much you owe the bank. Let's say it's a bank. The loan balance is how much you owe the bank. And clearly that balance is decreasing. So that means the amount owed is decreasing. Okay. This one is a little bit more respectable as a math problem. You're going to have to distribute this as a bonus. So 8a squared plus 24b squared minus 24b squared, like term, 8a squared, and this is plus 0 because these turn into 0. So ultimately it's just 8a squared, and then you're done. Okay, for my student watching this, hopefully this was helpful. Good luck on your tests. And for those of you not my student who are also watching, good luck on your tests in general. Okay, so I will talk to you all later. Bye.